Slope. Slope is a concept that will stay present in math for the rest of your life. Yes, even as you go up through AP Calculus, slope is a really important part of what we do. So for a linear function, because at this point we're dealing only with straight lines, for a linear function, the slope, which by the way, the rate of change is another word or another phrase that means the same thing as slope. So in the book or on a quiz or test, it might say find the slope. It might say find the rate of change. They mean the exact same thing. But for a linear function, a straight line, the slope is the same on the entire line. It never changes. It's a straight line, so it never changes how steep or how not steep it is. It never changes whether it's heading uphill or downhill. And another way to say that it's the same is to say that it's constant. It's unchanging, so it is constant. And this actually is helpful because it makes it a lot easier to find the slope, and we can do so, as we'll see in these notes, whether we are given a table, a graph, or a set of ordered pairs. And slope really does have a purpose in the real world, believe it or not. So slope describes the relationship between two variables. So you could look at how is the number of Taylor Swift fans changing over time. So time is one variable, moves forward. Taylor Swift fans, the number could go up or down. I have no idea, but we could figure that out. Could also look at how the price of apples is affected by the amount of apples harvested each year. Because if the season was really good and there were lots and lots of apples, they're likely going to lower the price of the apples so they can sell more of them. Whereas if there's very few apples that are harvested because of a drought or because of bad weather, a hurricane, anything like that, prices are likely to go up because those who are selling the apples still need to make money, so they have to make more money off fewer apples. So this is the slope formula. This is one you should memorize and put it to heart forever, because you'll need to know it for your entire middle and high school time in math. So for reasons I don't know, they call slope the letter M. No, it doesn't make sense to me either, but this is how it is. So when you see the letter M in math or in an equation, it represents slope. So to find the slope, we do y2 minus y1 over x2 minus x1. And these are not exponents. Notice they're written low. That's called a subscript. Exponents are written high. They're called superscripts. This is just saying use the y value from the second point and subtract from that the y value from the first point. So I put it here. This is the general form of the 2 points we'll be using. So this is the x value in the first point. This is the y value in the first point. This is the x value in the second point and the y value in the second point. So you do y2 minus y1 over x2 minus x1. So right here, you don't have to literally label these each time, but I'm going to the first time or two just to make sure you see how we're using this formula with these points. So this is our x1 because it's the x value in the first point. This is our y1 because it's the y value in the first point. This is our x2 because it's our x value in the second point. This is our y2 because it's the y value in the second point. So we do y2 minus y1, 10 minus 5. Pull it from that and that over x2 minus x1. So the y's always go on top. I know that may seem backwards because we want to be like alphabetical, but y's are always, always, always on top for slope. So then we just do the subtracting. 10 minus 5, 4 minus 3. And if you can reduce the fraction, go ahead and do it. So 5 over 1 can just be written as 5. There will be times you get negative numbers. That's fine. There will be times you just get fractions that can't be whole numbers. That's also fine. That's not uncommon at all with slopes. Okay, so let's follow the same pattern here. This is our x1 and our y1, because that's the x value and the y value in our first point. This is x2 and y2, because that's the x and the y value in the second point. So So y2 minus y1, 9 minus negative 3, over x2 minus x1. And we have to remember here that keep, change. These are both subtractions, so we do keep, change. Because we know minus a negative can always be changed to plus a positive. So 9 plus 3 is 12, 2 plus 1 is 3, 12 divided by 3 is 4. Okay, so number 3, we'll follow the same pattern. y2 minus y1, 3 minus negative 1. And if you'd rather write that as 3 plus 1 to start with, if you can see that ahead of time, that's fine. Negative 2 minus 5. So this changes to plus. 3 plus 1 is 4. Negative 2 minus 5 is negative 7. And this is an example I was referring to where it's a fraction, and we cannot reduce that fraction, we cannot make it a whole number, so we leave it just as is. And just so you're aware, it does not matter where you put the negative sign. If you wrote negative 4 over 7, that's correct. If you wrote negative 4 over 7 like that, that's also correct. So all three of these would be acceptable answers. Number 4, y2 minus y1 over x2 minus x1. 2 minus 2 is 0. This changes to a 3. And 0 divided by 3 is 0. So when 0 is in the numerator, that's the top of the fraction like it was here, then the slope is 0. And that happens when you have horizontal lines. Because a horizontal line is flat, it has no slope up or down. However, while we haven't seen this yet, if you ever end up with 0 in the denominator, then the slope is undefined. Or another way they say it sometimes is there is no slope. And that's because it's vertical line. So that really has no slope we can measure, because essentially the slope is, I don't know if this is mathematical, but I always think of it as the slope is infinite. Like it can't be steeper than that, it's straight up and down. So 0 in the top, slope is 0, that's a horizontal line. 0 on the bottom, the slope is undefined. That's what happens with vertical lines. Okay, so we've found the slope using ordered pairs. We're now going to find them using tables, which was the exact same method. Now, there are 5 points given here. Good news, you don't have to find the slope with every possible combination. You will get the same answer for slope no matter which 2 points you pick. So if you just want to pick the first 2 points each time, that's completely fine. If you like just going crazy, you can do like the first and the last point, or the first and the first point, or whatever. So I'll just do the first and the second point on this one, and then I'll do different ones over here. So this is my second point, this is my first point. So y2 minus y1, 17 minus 13, over 7 minus 5. 7 minus 13 is 4. 7 minus 5 is 2, so my slope is 2. Over here, I do have a typo. This should be 22 right here, not 23. Sorry about that. But let's just do the first and the last point on this one. So our second y, y2, that's negative 14 minus 2 on top. So y2 minus y1 over x2 minus x1. Negative 14 minus 2 is negative 16. 22 minus 10 is 12. And this fraction can't be a whole number, but it can be reduced. Those are both divisible by 4. So you divide the top by 4 and get negative 4. Divide the bottom by 12 and get 3. Okay, so the last way we're going to look at how to find a slope is when we're given a graph. So you might understandably ask, well, which one I count as the first point and which one is the second point? Because some people might very naturally just think left to right and think, okay, that's my first point and that's my second point. But other people might think low to high and think that's my first point and that's my second point. So I need to tell you a secret. It actually doesn't matter which one you call the first point and which one you call the second point. This equation works just as well if you do y1 minus y2 over x1 minus x2. You'll get the same correct answer either way. Now what's essential is that you do keep the x and y from the same point together. They either both have to be in the front or they both have to be in the back. So you can't mix up 2 points, but which order you put them in doesn't matter. And I want to show you the proof of that up here in number 5. Like I picked this to be the second point right here and this to be the first point. Well, let's think I'd reverse that. I treated this as y2 and I did 13 minus 17, y2 minus y1 over 5 minus 7, x2 minus x1. I would get negative 4 over negative 2, which, since they're both negative, negative 4 over negative 2 gives me positive 2, just like I got up here. So it was essential I kept the 17 and the 7 together, but it worked fine if they were the second numbers or the first numbers. Same with the 13 and the 5. They had to stay together, but it was fine for them to be the second point or the first point. So when you're choosing from 2 points on a graph, it doesn't matter which one you call y2 and y1. So I'll just treat this as y2 and I'll say y2 minus y1 over x2 minus x1. So that gives me negative 4 over 2, which is negative 2. Okay, on this one, I'll treat this as point number 2. So y2 right there minus y1 right there over x2 minus x1. So that gives me a 3 on top and a 6 on the bottom, which I can reduce to 1/2. And I do want to show you one other cool way you can find the slope on graphs. This only works with graphs. It doesn't work, the slope formula, that works with tables, graphs, ordered pairs, all that. But this next trick I'm going to show you only works with graphs. So another way slope is known is it's often called rise over run, because the y's are on top. They're the ones that tell you how high or low you go. The x's are on the bottom. They're how far they tell you left and right to go. So if I start at the point on the left, and this is important with the equation, it doesn't matter which one you call point 1 and point 2, but it's best when you're doing what I'm about to show you to start at the point on the left. So I first want to know how far I rise, or in this case, fall. So I start at that point, and I have to go down 1, 2, 3, 4 to get to be on the same level as the other point. So I'll write a 4 and a negative 4 because I went down 4. Then when I'm at that corner, I go to the right, 1, 2. So my rise was negative 4 because I went down 4. My run was positive 2 because I went to the right 2. And if you look, that gives me the same answer that the equation did. Or if you see, this actually is a point right here too. I could have just, if I'd seen that, I could have said I start here, I go down 2, 1, 2, over 1. And negative 2 over 1 is negative 2. Okay, we can do the same thing over here. Start at the point on the left. We need to go up 1, 2, 3. Go over 1, 2, 3, 4, 5, 6. See how those match? So we get 1/2. All right, last example, we want to talk about what the slope actually means in context. So someone went to buy computer games, and this is how many someone bought, this is how much they paid, this is how many someone else bought, how much they paid, and so on. So just like with the tables up here, you can pick whichever 2 points you want. Now, they said find the rate of change. Just a reminder that the exact same thing as slope. No difference, just a different term that means the same thing. So I'll just use the first 2 points, and I'll do y2 minus y1, y2 minus y1 over x2 minus x1. 156 minus 78 is 78. 4 minus 2 is 2. And 78 divided by 2 is 39. Or you could write it this way. You don't have to, but I'm explaining why that might help. So remember, this is the y's on top and the x's on the bottom. That's true all the way throughout. The y's on top, x is on the bottom. So y's represents cost. X represents the number of computer games. So I need to apply this to that bottom and apply this to the top. So what this means is that one computer game costs $39. Or I'm going to say each computer game costs $39. So by finding the slope, we actually determined how much each computer game would cost. So then, since we know that's a constant rate, it's going to go up $39 every time we buy a new game. How much would 9 computer games cost? Well, if one computer game costs $39, then we can multiply that by 9 and find that 9 games in total would cost $351.